All right, welcome to part 2 of 8.5 Properties of Logarithms. So in our last set of notes, we talked about how to take multiple logs and to rewrite them as a single log. Okay, so for example, in example 1, problem A, we took 2 logs and we said we can use property 1 at the top of our notes to combine these and put these written as one log. What we're going to do in example 2 is we're going to work backwards and we are going to expand one log and write it as 2 or more. So now we're going to work backwards. So if we come on down, let's call this example 2. Example 2 says expand each expression. All right, so here in problem A, we are given log base 4 of x, y. So what we're doing is we're working backwards from what we did last time. So last time we had multiple logs and we rewrote it as 1, and now we have 1 and we want to rewrite this as multiple logs. So we're going to look up at our log properties that are written on the whiteboard or at the top of our notes, and we're going to say which log property, 1, 2, 3, or 4, has 2 logs, has 2 pieces in the argument that are getting multiplied. So show me on your hand which log property has 2 pieces in the argument that are getting multiplied. Good. Log property number 1. So if you take a look at log property 1, it says if I have 2 logs getting added, I just multiply the arguments. So what that means if we work backwards is if I multiply the arguments and I want to expand them, I just need to rewrite this as 2 logs that are being added. So we used property 1 and we went backwards. So 2 pieces in the argument that are getting multiplied. I can expand it and write it as 2 logs that are getting added. Let's do another one. We'll call this example B. In example B, we're given log base 4 of x over y squared. Okay, so take a look up at the log properties and tell me which log property has 2 pieces in the argument that are getting divided. So show me on your hand which log property, 2 pieces in the argument getting divided. Log property 2. So if I have log property 2, I know that I want to rewrite these as 2 logs that are being subtracted. So I'm going to rewrite this as log base 4 of x minus log base 4 of y squared. Now, when we expand expressions, we are also going to take any exponents we have and move them. So we happen to have a y squared, and I want to move the 2. Which log property says that I'm allowed to move the 2? So take a look up at the board or at the top of your notes. Which log property says I'm allowed to move an exponent? Good, most of us have it. Log property 3. So log property 3 says if I have an exponent, I'm allowed to bring it down out front. Or if I have a coefficient down out front, I'm allowed to bring it back as an exponent. Oops. So then I'm going to rewrite this as log base 4 of x minus 2 log base 4 of y. So we would call this fully expanded. All right, let's take a look at another one. We'll call this example C. In example C, we've got log base 3 of the square root of ABC. Now, when I'm first starting this problem, it's really easy to think, oh, I have a log and I have a bunch of stuff getting multiplied in the argument. However, all that stuff getting multiplied in the argument is trapped under a radical. So the first thing I'm going to have to do is deal with that radical and get rid of it. Now, the way we get rid of a radical is we're going to change this to exponential form. So I know that a square root is really the what power? So if you of you are showing me that it's the second power, it's not the second power, it's the what's the index number? Show me on your hand. What's the index number of the square root? There's nothing written there, so what's the index number? Good, it's a 2. And so when I bring this back, this is going to be the 1/2 power. Another way to think about this is you're taking this 2 and you're bringing it back on each variable inside. Okay, so when we change forms, this is really log base 3 of a to the 1/2 power, b to the 1/2 power, c to the 1/2 power. Because the 1/2 power is just the square root. So now that I've gotten rid of the radical, I've got 3 pieces in the argument that are getting multiplied. So when I want to expand this, I'm going to use property number what to write this as multiple logs. So show me on your hand, what property has pieces in the argument getting multiplied? Okay, so we should be saying property 1. So property 1, if you look on the right side of property 1, it says log base b of x times y. So those are 2 pieces in the argument getting multiplied is equal to log base b of x plus log base b of y. So I can split them up by just adding them. So this is going to become log base 3 of a to the 1/2 plus log base 3 of b to the 1/2 plus log base 3 of c to the 1/2. Okay, so that was property 1 to split them up. Then, just like the last problem, to fully expand this, we need to take our exponents and bring them down out front as coefficients. Which log property says we're allowed to take exponents and bring them down as coefficients? Show me on your hand. Which log property is that? Good, so that's going to be log property 3. Log property 3 says I can take an exponent and drop it out front as an exponent, or I'm sorry, as a coefficient. So now we would call this fully expanded. So what we're doing is we're working backwards. Last class, I gave you a big long expression with multiple pieces and I said rewrite it as one log. This class, we're taking one log and we're writing it as multiple pieces. Okay? So let's do another one. We'll do one more to practice. So we'll call this example D. Let's give ourselves a little bit of space. In example D, I've got log base 7 of x cubed over y to the 5th power. Now, there are actually two ways that I could start this problem. So I could either start by bringing that exponent down out front, or I could take that exponent and make it x to the 15th, y to the 5th. Whichever way you want to start this problem, it doesn't matter. I'm going to go ahead and take that exponent 5 and I'm going to move it inside the parentheses. So I'm just going to simplify that piece. And I know that x to the 3rd to the 5th power is really x to the 15th. And then y to the 1st to the 5th power is really y to the 5th. Now, when I want to expand this, I'm thinking, okay, I'm looking at the log properties and I'm saying which log property has two pieces in the argument that are being divided. So look over at the whiteboard and look at the log properties. Which log property has two pieces in the argument that are getting divided? Show me on your hand. Okay, so I'm looking at log property 2. Log property 2 says if I have two pieces getting divided in the argument, I can split them into two logs and subtract them. So this is really log base 7 of x to the 15th minus log base 7 of y to the 5th. We use property 2 here. Now, am I finished expanding this? Give me a head nod. Yes, I'm finished, or no, I'm not finished. There's one more thing that I can do. So everybody give me a head nod. Am I finished expanding this? Just like the last problem, I am not finished expanding this because I need to take the exponents and I need to bring them down out front as coefficients. So we're going to take our exponents and we're going to bring them down as coefficients. And now we are fully expanded. Okay, so now we're going to go into our next example, and we're going to take a look at using the same idea to help us make some estimations. So let's give ourselves some space. We'll call this example 3. And example 3 says, use the following to estimate. And then we're given two pieces of information. So the two pieces of information for these problems that were given, they give us log base 4 of 3 is equal to 0.7925. And they tell us that log base 4 of 2 is equal to 0.5. So our goal is to use these two pieces of information to estimate something else. Okay? So here in problem A, they tell us to estimate log base 4 of 32. Okay, and we have to use our two pieces of information to do that. So the way we do these problems is we look at what they gave us, and we look at the problem we have, and we say, how can I break my argument into 3s and 2s? So I'm looking at the argument. The argument's 32. Can I break 32 down into 2s and 3s? How does 32 break down? Okay, so 32, let's see. If we drew a factor tree, that might be a good way to start. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So I know that 32 is 2 to the what power? Show me on your hand. 2 to the what power? Good, so it should be 2 to the 5th. So what I'm going to do is I'm going to come in here and I'm going to say, I'm going to rewrite this. Log base 4, instead of 32, I'm going to write 2 to the 5th. Then what I want to do, I want to bring that 5 down out front because I want to fully expand my expression. So I'm going to bring the 5 down out front. So I have 5 times log base 4 of 2. Do I know what log base 4 of 2 is? What is it? Log base 4 of 2 is just what? It's just 0.5, because that's the piece of information that they gave us. So we're going to make a substitution. This is really 5 times 0.5. And 5 times 0.5 is just 2.5. So I can estimate that log base 4 of 32 is just 2.5. Okay, let's take a look at another one. Example B, they give us log base 4 of 192. So we're going to do the same thing. We just have a bigger argument, 192. So I'm thinking, okay, 192, I want to break that down into either 3s or 2s. Okay, so I'm thinking 192. Well, 192 is divisible by 3. So it's 3 times 64. Sixty-four is 2 times 32. And then what did we just say that 32 is? 32 is what? 2 to the How many? Good, 5. So we said 32 was 2 to the 5. So we could go 1, 2, 3, 4, 5. So we already know 32 breaks down into 5 2's. So now if I want to rewrite 192, I should rewrite it like this. Log base 4 of 2 to the what power? How many 2's were there? How many did it break into? Show me on your hand. Good. It broke into 6 and a 3. Okay, so I've broken down 192. Now I need to fully expand this log. So I need to fully expand it. So let's think about this. The argument has 2 pieces that are getting multiplied. So I'm going to look over at my log properties and I'm going to say which property has 2 pieces that are getting multiplied in the argument. So take a look at your log properties. Which log property has 2 pieces that are getting multiplied in the argument? Show me on your hand. Good. Property 1. Property 1 says if I have 2 pieces in the argument getting multiplied, I can split them up to 2 logs that are getting added. Is this fully expanded? Good. I've got some people saying no. This is not fully expanded because I need to bring this exponent, the 6, down out front. So this is really 6 times log base 4 of 2 plus log base 4 of 3. Is everything fully expanded now? Give me a head nod, yes or no. Is everything fully expanded now? Yeah, everything's fully expanded. So now let's just do a substitution. So if I look at the top of the problem, the stuff that they gave me, they said log base 4 of 2. They told me what that is equal to, so it's just equal to 0.5. So I'm going to substitute that in there. Then log base 4 of 3, they told me that that's equal to 0.7925. So I'm going to substitute that in there. And so now I've substituted numerical values so I can estimate what log base 4 of 192 is. So I'm going to grab my calculator. I'm going to do 6 times 0.5, which is 3, plus 0.7925. So I get 3.7925. Okay, so I can estimate that log base 4 of 192 is equal to 3.7925. Okay, let's try another one. On this next one, they give us log base 4 of 3 over 2. Okay, I want you to go try this one on your own. Log base 4 of 3 over 2. It's already broken into 3's and 2's, so go expand it and then estimate it. So I want you to go try this problem. So you need to expand the log, substitute in, and estimate. Once you have an answer, take a look up at the board, or I'm sorry, the TV monitor, okay, and check your answer. once you've finished this, go check your answer with what I've got up on the TV monitor. So the first thing we do is we say, okay, I have two pieces in the argument that are getting divided. I know from log property 2, if I want to expand this, I'm going to write it with two logs that are being subtracted. So I rewrote this as log base 4 of 3 minus log base 4 of 2. Then I substituted in the two pieces of information that they gave me. So I said 0.7925 minus 0.5, and that is equal to 0.925. Give me a thumb, either thumbs up, it went well, a thumb in the middle, it went okay, thumb down, it went really bad. Okay, good. Let's try another one. The next one, example D. This one's going to be very similar, but we're actually going to look at a new trick. So this is log base 4 of 1/2. Okay, so we're going to look at a new trick. It's actually we're going to add it onto our log properties. So on this one, same thing. I see I have two pieces that are getting divided, so I'm going to split it into two logs. So this is log base 4 of 1 minus log base 4 of 2. And you might be thinking, but Mrs. Bates, we don't know what log base 4 of 1 is. And so we're actually going to go back up to the top of our notes, and we're going to add in one more log property. So let's come up to the top of our notes. And off to the side, we're going to write log property 5. And we're going to write log base B of 1 is equal to 0. And the reason why is because if we think about a graph of a log, we have our asymptote along the y-axis, and it looks like this. So it always goes through the point 1, 0, and then depending on B is where the other points hit. But we know that log base B of x looks like this. It always goes through the point 1, 0. That's the point that does not change. So what that tells us is that if we take log of 1, we're going to get 0. Okay, so we're going to add this in as our log property number 5. If we take the log of 1, we're going to get 0, because 1, 0 is always a point on our graph. Okay, so let's go take a look back at our problem. So if we scroll back down to our problem, I know that log base 4 of 1 automatically is 0. Then I'm just going to substitute that log base 4 of 2. They told us in the original problem, log base 4 of 2 is just 0.5. And I know 0 minus 0.5 is just negative 0.5. Okay, let's do another one. So I'm going to go back over to the left side of my page. Call this example E. We're going to do 2 more of these. So in this one, we're given log base 4 of 27. Okay, so I'm thinking again, how can I break 27 down into either 2s or 3s? Because The information they gave us had a 2 and a 3. So I'm thinking, can I break 27 into 2s or 3s? And the answer is yes. We know that 27 is 3 to the what power? Show me on your hand. 3 to the what power? Good. 3 to the 3rd. So this is log base 4 of 3 to the 3rd. Is this fully expanded? No. What do I need to do with that 3rd power? Good. I need to bring it down out front. So this is really 3 times log base 4 of 3. I know what log base 4 of 3 is because the original problem told me it's just 0.7925. And so I can estimate that log base 4 of 27 is 2.3775. Okay, on our next one, we'll call this example F. We're going to look at one more kind of trick for these problems, and we're going to take a look at log property 4, which we have not used yet. Okay, so in example F, we're given log base 4 of 24. Okay, so we want to use property 4. If you take a look at property 4, so look up at the whiteboard or scroll up in your notes, take a look at property 4 up on the whiteboard. In property 4, there's an exponential function, b to the x, and it's getting plugged into a log. Now, we know that logs and exponential functions are inverses. So what's happening when we take log base b of b to the x is the inverse property is getting rid of them. So they kind of cancel each other out, and we're left with whatever the exponent is. Okay, so that's why if you look at the whiteboard, log base b of b to the x is just equal to x, because of the inverse property. So when I look at these problems, for example, F, one of the things that I'm thinking is, whatever the argument is, 24, can I divide it by the base? So does 24 divide by 4? Yeah, so when I'm thinking about doing this problem, one of the shortcuts that I want to use is this. I want to use the fact that log base 4 of 4 is going to be equal to the exponent. So what I'm thinking is, okay, 24 divided by 4 is 6. Now can 6 break into the piece of information that I have? The 2 and the 3? Yeah, because 6 is just 2 times 3. So all I did was I broke this down, and I used the base as one of my pieces. So 4 times 2 times 3 is still 24. Is this expanded? No. So let's go expand it. Log base 4 of 4 plus log base 4 of 2 plus log base 4 of 3 . And property 4 says that log base 4 of 4, these two things get rid of each other, and I'm left with the exponent. What's the exponent here on this 4? That we don't write because it's redundant. What's the exponent? Show me on your hand. It's a 1. So the log 4 and the base 4 get rid of each other, and I'm left with 1, the exponent. So then I know this is just 1 plus, and then log base 4 of 2 is 0.7925. and log base 4 of 3 is 0.5. So when I grab my calculator and I add these all together, I get 2.2925. Okay, so we're going to do one more example, and we're looking at one more type of problem. So we'll call this example 4. Is it example? Yep, example 4. And example 4 says to solve. So now we're going to use our log properties to solve equations. Okay, so here in problem A, we are given log base 6 of x plus log base 6 of x minus 9 is equal to 2. Now, these problems are going to pull lots of information from the whole chapter. So we're going to be pulling lots of information, not just from this section. The very first thing that I want to do is I want to condense my two logs. I want to be able to write these two logs as one log. So taking a look up at the whiteboard, which log property says if I have two logs getting added, I can combine them. So show me on your hand, which log property has two logs getting added? Very good. Log property 1. So what I'm going to do to combine them is multiply the arguments. So I'm going to take x times x minus 9, and that gives me x squared minus 9x. Now the directions say to solve. So that means I'm trying to get x by itself, but right now both of my x's are trapped inside the log. So the way that we are going to untrap them and get them out of the log is by changing forms to exponential forms. So I'm thinking in my head, okay, if I want to change forms, I know that logs are BAE. So I'm going to go ahead and label BAE. And in exponential form, I know that I have a base 6 raised to an exponent 2 equal to some answer, x squared minus 9x. Now this should look pretty familiar for us. So we've got x squared minus 9x equals 36. I know that to solve this, because I have an x squared, it's quadratic. So to solve this, I need to move the 36 over. And what am I doing with this? How do I solve something like this? We've been doing this since semester 1, almost day 1. So we've been doing this for a while. How do I solve something like this? Very good. I'm going to use the big X. Nice job. Okay, so we're going to use the big X. I've got negative 36 on the top, negative 9 on the bottom. My two side numbers are going to be negative 12 and positive 3. Because there is nothing out front of here, do I need to divide the two side numbers? No, we don't. So we're going to just say, all right, well, this is x minus 12, x plus 3. When I set them equal to 0, I get x equals 12, x equals negative 3. Can anybody think of a reason we might not be done? Very good. We do need to check our answers. Okay, so we need to check our answers. And what we mean by that is we are going to plug into the arguments because the arguments cannot be 0 or negative. So go ahead and write this down. Make sure you write this down, because when you get home and you're working on homework, you need to know, why did we check these? Or how did we check these? What were we looking for when we checked these? So make sure you write this down. Okay, so here's what we're going to do. We are going to take 12. I'm going to go back up to the original problem, and I'm going to plug 12 in here. If I plug 12 in here, now the argument is 12. Is 12 negative? Give me a head nod. Is 12 negative? No. Is it 0? No. So is 12 an answer? Yes, so we could come down here and box 12. 12 is one of my answers. Now let's go plug in -3. Oops, we also need to plug 12 in for the other argument. So let's also plug 12 in here. If I plug in 12 here, 12 minus 9 is 3. Is 3 bigger than 0? Yeah, which means that, so it's not negative and it's not 0, so 12 does work. Let's plug -3 in. If I plug -3 into the first one, I get log base 6 of -3. Can I take the log of a negative? No. So is -3 an answer? No. So because it makes my argument negative, we cannot use it. Okay, we're going to do one more, and then we'll be done with the 8-5 notes. We'll call this example B. In example B, we're given 2 log base 7 of x is equal to log base 7 of 27 plus log base 7 of 3. The very first thing we want to do on this problem is condense both sides. So if I want to condense the left, I've got to move the 2 back as an exponent. So that's log property number 3 that says I'm allowed to take this 2 and move it back as an exponent. So this is log base 7 of x squared. If I want to condense the right side, so if I want to write it as a single log, I'm thinking, okay, I have 2 logs that are being added, so what should I do with the arguments? Or which log property is it? So take a look up at the whiteboard. Everybody look at the whiteboard. I have 2 logs that are being added. Which log property is it? Good. Log property 1, which says to do what with the arguments? Multiply. Okay, so 3 times 27 is 81. And then from the last set of notes, I don't know if you remember this because we've done a bunch of stuff, but from the last set of notes in 8.4, we said if we have 2 logs that are equal to each other, we can just drop down the arguments, get rid of the log part, and then solve. So how do I go from x squared down to x? I take the what? Somebody said it, the square root And then because I brought in the radical, there's not a radical in the original, I know that x equals 9 and x equals negative 9. And the last thing I need to do is check. So when I check, I'm going to plug these in for the arguments and make sure I'm not 0 and I'm not a negative number. So the only argument to plug something in is right here. So if I put a 9 in there, the argument is now 9. 9 is not 0, and 9 is not negative. So is 9 one of my answers? Very good. Yes, it is. If I plug in negative 9 to that highlighted yellow spot, is my argument 0? So the argument's not 0. Is the argument negative? Yes, and I cannot have a negative argument, so I get rid of it. All right, that is all I have for you for the 8.5 Part 2 notes. As always, if you have any questions, watch this video again or shoot me an email.